Hello everyone and welcome back to another video on Thinknyx tutorial series. This video tutorial is prepared by Dheeraj and presented by Kanishk. In our previous video, we explored the Thinknyx configuration file. But do you know how websites manage traffic efficiently while maintaining security? That's where proxies, reverse proxies and load balancers comes in. In this video, we'll break down the difference, how they work and when to use each. So let's get started with proxy. Proxy server act as an intermediate between the user and the internet. When you send a request, the proxy forwards it to the target server and returns the response. This hides your IP address, enhancing privacy and security. Here are few use cases of proxy. Privacy. It masks user's IP address, helping with privacy. Content filtering. Proxies used by organizations to block or allow specific websites. Caching. It stores copies of frequently accessed web pages to speed up load times. Security enhancements. Proxies can help prevent direct access to potential malicious websites. For example, when you use a VPN, it often functions as a proxy, making it appear as if you are browsing from a different location. Now, let's move on to reverse proxy. Unlike forward proxy that sits between the user and the internet, the reverse proxy sits between client and backend server. It receives requests from the user, processes them, and forward them to appropriate server. The server's response then goes back through the reverse proxy to the user. Here are few use cases of reverse proxy. Security. It hides internal server from direct exposure to user. SSL termination. It handles encryption and decryption of HTTPS traffic to reduce server load. Load balancing. It distributes traffic among multiple backend servers. Caching and compression. Reverse proxy improve performance by caching static content and compressing responses. Now let's understand load balancer. A load balancer is specifically designed to distribute incoming traffic across multiple backend servers to ensure high availability and reliability. It helps prevent any single server from being overwhelmed, ensuring smooth performance. Here are few types of load balancers. Layer 4 load balancer operates at the transport layer TCP UDP and distributes traffic based on IP addresses and port. Layer 7 load balancer works at application layer HTTP HTTPS and makes routing decisions based on request content. Let's move on to use cases of load balancer. Traffic distribution. It ensures no single server is overloaded. Fault tolerance. If one server fails, the load balancer redirects traffic to available servers. Scalability. Load balancer supports horizontal scaling by adding or removing servers as needed. SSL terminations. Like a reverse proxy, it handles HTTPS encryption. Session persistence. It ensures that the user session is maintained by directing repeated requests to the same backend server. Health checks. Load balancer continuously monitors backend servers to detect failures and reroute traffic accordingly. Example, AWS Elastic Load Balancer, ELB, Nginx and HA Proxy are popular load balancers used in production environments. Now, let's go over the key differences in a structured way so you can understand when to use each component. Primary role. A proxy is used to act as an intermediate between the client and the internet, hiding user's identity. A reverse proxy serves as the intermediate between the client and the backend server, adding security and performance optimization. A load balancer is designed to distribute traffic among multiple backend servers, ensuring high availability and efficiency. Location in network. A proxy sits between the user and the internet, forwarding requests on behalf of the user. A reverse proxy sits between the user and the backend server, protecting the servers from direct access. Load balancer is placed in front of multiple backend servers and intelligently distributes requests among them. Main purpose. The primary purpose of proxy is to enhance users' privacy and security while accessing the internet. The reverse proxy focuses on the server-side performance, security, and caching. Load balancer ensures system scalability, fault tolerance, and availability by distributing incoming traffic efficiently. Security benefits. A proxy protects the user's identity by masking their IP addresses. A reverse proxy enhances backend server security by preventing direct access or filtering malicious traffic. A load balancer protects servers from overload but does not provide anonymity or advanced security features like reverse proxy does. Load balancing capability. A proxy does not perform load balancing. A reverse proxy can provide load balancing on a secondary function, distributing traffic amongst backend servers. A load balancer, however, is specifically designed to balance load across multiple servers as its primary function. Caching functionality. A proxy and a reverse proxy can cache content to improve performance and reduce latency. However, load balancer does not typically perform caching as its primary function is traffic distribution. But when to use what? You can use a proxy when privacy, anonymity, and content filtering is needed. Reverse proxy can be used when you want to protect backend servers, caching content, handling SSL termination, or mitigating DDoS attacks. You can use load balancer when managing high traffic, ensuring high availability, and distributing load efficiently among multiple servers. So that's the difference between proxy, reverse proxy, and load balancer. Each serves a unique role, and knowing when to use them can greatly improve security, performance, and scalability in network architecture. If you found this video helpful, don't forget to like, subscribe, and comment below with the questions. See you in the next one. Thank you.